Alright, for this we're going to talk really briefly about first-class lever examples when maybe we're trying to find our resistance or our mechanical advantage. So we're just going to do those for first class, and then we'll go through a couple other videos for the other classes. Alright, so for right now, we're going to look at something similar to those first problems in 1.1.2. So we're going to go with a lever. It says it's in static equilibrium. Alright, we're going to have our fulcrum in the middle since it is our first class. Remember, our fulcrum is the pivot point, wherever it pivots. And it's going to have, let's say, we're going to do a effort force of 20 pounds. Okay, and then we're going to have a resistance force of 100 pounds. Okay, can we see that? There we go. Alright, so what we need to know at least one of our distances, and then we will work from there. Alright, so we know that our effort force, let's say, is going to be 5 feet from the fulcrum. Alright, so here we go. We've got, again, this is going to be our effort distance. That is really hard to see. Sorry about that. It's a capital D with our subscript E. Let's actually zoom in a little bit here. Okay. So, we've got our FE, our effort force, is 20 pounds. Our FR, our resistance force, is 100 pounds. Our DE, our effort distance, is 5 feet. And we do not know our DR. And that's okay. So, we're going to work through that. So, for most of these, it just asks you to draw the system first, and then it'll start to ask you questions. Alright, so I'm going to show you how to find our actual mechanical advantage of this system. Alright, so actual mechanical advantage, remember it's AMA, and it is our resistance force divided by our effort force. And we know both of those values, so we can just plug that into our equation right here. So our FR was 100, so we put 100 pounds. Our FE was 20, so we put 20 pounds. Make sure you're including your units, because they will cancel out in this case, but some other problems that we do, you might need to actually know what's left over. Okay, so please just make sure you're using those units. So we simplify this. Our pounds cancel out. We can technically cancel this and say 10 divided by 2, or just do your 100 divided by 20, however you'd like, and you'll get 5. Alright, our AMA would be a ratio of technically 5 to 1, so it's 5 times easier to do, but it's 5 times the distance. Okay? When we take a look now, we want to do our static equilibrium to figure out what our distance was for our resistance force. Okay? Remember the one number we didn't know before? We want to find that out. So we're going to use our equilibrium formula. So for equilibrium every single time, we're going to do our resistance force times our resistance distance is equal to our effort force times our effort distance. Okay, so just remember, resistance is all on one side, effort is all on the other. Okay, and you're multiplying them together. Alright, so we know our resistance force, so we can put 100 pounds here. Okay, we don't know our DR, so that stays DR. If you'd like to replace it with a variable like X, that's perfectly fine if that's what helps you. Alright, for our effort force, we know that it's 20 pounds. Alright, and our effort distance we know was 5 feet. Okay, so all we need to do is solve for DR. So what we can do is we can simplify this side over here. So we know 20 pounds times 5 feet is going to be 100. Remember to keep your units, so this is going to be foot-pounds now, at least for now. And then we can rewrite this just to bring it down. Okay? Now we really want DR by itself. So since we have 100 pounds times DR, we can divide by 100 pounds on both sides of our equation to make sure we move it from this side to that side. Okay, so let's take a look. We divide by 100 pounds. Okay, we divide by 100 pounds. So this one is actually a little interesting since the numbers that I chose. But our hundreds and our pounds cancel on this side, just leaving us with dr. Okay, our pounds definitely cancel on this side, but our hundreds cancel as well, which actually just means we're left with 1 foot. Okay, depending on your numbers, usually you'll wind up with a different value for this. But if we noticed here, we had our 5-to-1 ratio, so 5 here, we have 1 here, 1 foot. Alright, and that's most of what we would do for a first class lever in finding our AMA and finding our static equilibrium equations.